Before we go into graphing lines again, you need to learn a little bit of different type of algebra. You guys are used to this. I'm not writing stuff. 2x plus 10 equals, I don't know, 6. How would you solve that?
Yeah, I can try 10 for the side.
Yeah.
And then you did what?
2x is equal to? Remember, since you guys have been solving equations so much now, you may get to the point where you're saying, you know, I really don't need to write that because I can do it in my head. And that's fine if you want to do that. If you're still not sure about equations and this makes you feel a little bit more comfortable, write it in. For sure. All I'm saying is that this is optional. It doesn't have to be part of this. Okay, so that's an equation. We always get a number for an answer or a solution. These ones are a little different. What looks different about these? There's no numbers and there's different letters. It's usually just X or just Y or just Z with some numbers. We can still solve these. I want to solve this for X. What does that mean? Get X by itself. Yes. So how do I get X by itself? I subtract Y from both sides.
Is it Z1?
And I get, well, hang on, what is it?
You don't know.
Over?
So why would we say?
Over? I'm not dividing by Y. So why would you go over?
Is it Z minus Y?
Yes. It's Z minus Y, right? And I can't put those together, can I? So this is your answer. You stop. You can't go any further. I know, it's a little weird. But there's a reason why we do it. Okay? Because there's going to be certain types of graphs where we're going to have to do this type of equation solving. This is called a literal equation. You don't need to know the name of that, but that's what it's the name. Okay. This one. Solve for S. Get S by itself.
No. Is it divide by 4?
Oh, I want not divide by 4S, just by 4, because that leaves S, which means whatever I do to one side, I have to do to the other.
Is it P over 4 means?
P over 4 equals S. You can't go any further. So you stop. This one, a little bit more challenging because there's a couple of steps.
Is it 4, 6,
So first of all, I got to move the 6 over, correct? And I'm left with 2y.
equals 6x?
No, it's x plus 6. It's not times. So you have to write it like this. Now what? Well, how do I get y by itself? Don't overthink. Divide it by 2. Whatever you do to one side, do to the other side. Divide it by 2. So you get y equals x plus 6 divided by 2. Or you could do this, and you should get used to this. Remember when we divide more than one term by one thing? We do the first term divide 2 plus the second term divide 2. Well, there's an easier way to say 6 divided 2. What's an easier way to say 6 divided 2? 3. So that means the same thing as this, but you should really try to get used to doing it like this. Okay? So we're going to leave that for now, because we are going to see some equations in this lesson where there's some fractions involved, where we have to graph. Okay. Oh, sorry, we got one more. I thought we were done. Fraction equation, I hate fractions. How do I get rid of fractions? Yeah, what can I multiply this by to get rid? What can I multiply this by to get rid of 3? And whatever you do to one thing, you have to do the same thing to all of them. I times everything by 3. Why? Because 3 divided 3 cancel each other out. I don't want the fractions. Fractions are too hard to work with when we're solving. We want to get rid of them. Careful. A plus 3b equals 3c. Because remember, to get rid of the fractions, you times by the lowest common denominator, but there's only one denominator here. I still don't have a by itself. Subtract 3b to get rid of that. Subtract 3b. And my equation is going to look like 3c minus 3b. And those aren't like terms, so I can't put them together. So I'm done. Okay. Now, we're going to return to graphing. These are just the steps involved. When, and this is graphing equations that have y and x in it. They're not problem-solving situations. They're just on a 4-quadrant grid. Okay? So the first thing you do is you got to make sure y is by itself. Like in that previous lesson, when I showed you that previous exercise 7.2, all those questions, y was by itself on the left. So we got to make sure that happens, because sometimes it doesn't. So we got to change it. Then we make a table of values. We plot the points, draw a line through. So we're just going to do some examples. Actually, we're not going to do this just yet. I'm going to do one that's sort of a warm-up. So I want you to just write this one aside. Y equals 4x minus 3. Before we jump into the fractions. Minus 3. No, we're graphing it now. Y is already by itself, right? We're solving for y. So y is already by, I don't have to do that in this question. What I do have to do is make a table of values. What did I say to choose for x? What 3 numbers? 0, 1, and 2. Those are the easiest ones to work with.
Oh,
Okay.
so you do back to the like
Yeah. So we have to do 4 times 0 minus 3. It's negative 3, because 4 times 0 is 0, minus 3 is negative 3. So one of my points that I need to graph is 0, negative 3. Got 1. I need more than 1 point to draw a line. So 1. What is 4 times 1? Minus 3. 1. So another point is 1, 1. And finally, what is 4 times 2 minus 3? That's 4 times 2 is 8. 8 minus 3 is 5. Good. Those are my 3 points. And remember, when I plot them, they should look like I can easily draw a line through it. If they don't, I've made a mistake somewhere. Like if you plot, don't plot this yet, because I'm going to plot incorrect ones. Like if you did your table of values and it ended up with something like this, I've made a mistake somewhere, because those you can't draw a line through. Okay, so somewhere I made a mistake. So you have to check your work. But this one, I think we're okay. So 0, -3, 1, 1, and 2, 5. Yeah, those ones look like they form a nice line. Remember, you have to draw the line through it. And arrowhead in the end. So this is a visual picture of the equation. Y equals 4x minus 3. When there's no fractions and y is by itself, it's pretty straightforward. But let's look at this one. I'll use different color. Well, first of all, y is by itself, so I don't have to do any algebra. I can go right into my table. And what did I say you should choose for? Right, okay, but don't write it yet, because 0, always choose 0, I said. So what is 1/4 times 0 subtract 2? Well, what is 1/4 times 0? 0 subtract 2 is -2. Here's the problem if I choose 1. If I choose 1, do you see how I'm going to get a fraction for an answer? How do you plot a fraction? It's hard. If I plug 2 in here, I'm going to get a fraction. Can you think of a number to plug in here that when you calculate it, it won't give you a fraction? What could I plug in here so that when I multiply it by 1/4, 4. Because watch what happens. 1/4 times 4, which is the same as 4/1. Well, what's 1/4 times 4/1? No. What's 4/4 the same as? So this is 4/4 minus 2, but that means the same thing as 1 minus 2, which is what? -1. So that's another point. So do you see that if we chose 1, 2, or 3 in this case, we get a fraction? We don't want fractions. What do you think the next value of x you choose? Follow the pattern. 8. Because if I plug in 8, I get 1/4 times 8/1 minus 2. Well, what's 1/4 times 8/1? That's the same as 8/4. 8/4 is the same as 2 minus 2, which is 0. So therefore, my third point is 8, 0. So you've got to be careful in your choices when there's a fraction in the equation. So we need to plot these 3 points. 0, -2, which is here. 4, -1, which is here, and 8, 0, which is here. Notice how they form a nice line. That means I must have done all my calculations correctly. And that's the graph of y equals 1/4 x minus 2. Okay. Okay. Before we move to the next example, you don't have to write these down. All I want you to tell me is what numbers you would choose. I'm going to give you an equation. You tell me what numbers you choose for x. For a table of values. If the equation was that, you were asked to graph it, what would you choose? 0, 1, and 2. If the equation was this, what would you choose for x? 0, 5, and 10. If the equation was this, what would you choose for x? 0, 3, 6, or -3 would work. If somebody said -3, that would work. But we don't want to choose numbers that when we do our calculation, we're going to get a fraction, because it's really hard to plot fraction coordinates. It's not impossible, but it's really hard. And that's not very exact. Okay. Next example. What do you notice about this equation? Y is not by itself. So I can't start a table yet. So this goes to back what we did at the beginning of this lesson. I need to get this over here and this over here. How do I move the 2x? Minus 2x, minus 2x, and I get y plus, or sorry, there's still a minus 2 equals -2x. All I did was move the 2x, but there's still a minus 2 here. How do I get rid of this? Plus 2, whatever you do to one side, you got to do to the other.
Isn't it y equals x?
Oh, these are not like terms, are they? I can't combine them. No, it's just -2x plus 2. Yeah. You can't combine those because they're not like terms. You can't make it -4x or 0 or whatever. You can't do that. Now we can do a table. What would you choose for x? 0, 1, and 2 in this case, because there's no fractions I have to worry about. Okay? So for y, it's going to be -2 times 0 plus 2. Yep. 0 plus 2 works out to 2, so one of my first point is 0, 2. My second point is that I plug in 1 for x. What is -2 times 1 plus 2? 0. -2 times 1 is -2, plus 2 is 0. So my second point is 1, 0. And then -2 times 2 plus 2 works out to -2. That's correct. Because this is -4 plus 2, which is -2. So I want you to go ahead and plot those points and draw a line through them. I'll wait for a second. I'd like you to do it. I've already passed through like that, so. Hopefully they form a line, those points. So 0, 2. 1, 0. What was 2, negative 2?
Yeah.
And 8. Remember, we're not done. We go. Okay, the last one of this type. Here we have another equation where y is not by itself. So we've got to do some algebra to get y by itself. First of all, we need to get rid of the 3x. Minus 3x, minus 3x. Now, that leaves you with minus 2y on the left-hand side. Now, I'm going to write this first, because doesn't the x always come before the number? So I'm not going to do 6 minus 3x. I'm going to do negative 3x plus 6. Okay? Yeah.
Oh, no, never mind. Regardless.
Right.
I don't know if you could do like, it would be like negative x or whatever. Because you'd be.
Yeah, you can't combine them. Yeah. Oh, careful. How do I get rid of this?
Oh, divide.
Divide by negative 2. Now, this will get you, instead of doing the whole thing, divide each one by negative 2. This will get you to the final answer quicker. Because remember, whatever you do to one thing in an equation, you got to do the same thing to everything. So I'm left with y. Can I divide this and get a nice answer? No, but 2 negatives make
Positive.
a positive. So the best I can do is 3x over 2. That's okay. We know how to graph those now. But this, is there a cleaner way to say this? Negative 3. Now we're ready to make our table. But remember, we got a fraction in this equation. We always want to choose 0.
Would it be 0 and then
Because the denominator is 2, choose 2, and then follow the pattern to 4. So what is 3 times 0 divided by 2 subtract 3? Well, let's follow it through. What's 3 times 0? 0 divided by 2. Still 0. 0 minus 3. So that's one of my points. 2.
6 over 2.
So 3 times 2 is 6. 6 divided 2 is 3, and subtract 3. So I get 2 comma 0. And finally, 3 times 4 divided by 2, and then subtract 3. So yes, 3 times 4 is 12 divided by 2, minus 3 is 3. Excellent. Get a plot and graph. Get a plot and draw a line to it. So 0, negative 3 is here. 2 comma 0 is here. It's the last one. 4 comma 3. 4 comma 3 is here. I made a mistake. What mistake did I make? Nope.
So is that on screen?
Yeah, I made a mistake. I did 3, 4. So you see how it's kind of it's neat how you can sort of pick up errors that you make. Saying, well, wait a minute, that's wrong. What did I do? And there we go. I know there's only a couple pages left, but I'm going to save that for next week because I think we've done enough that we can get some practice now. Okay, so what I would like you to do for Wednesday is I want you to do just 1 to 5 in exercise 7.3. So exercise 7.3, 1 to 5, it's everything we did today. Where you had to solve literal equations and then you had to graph lines.